Hello everyone, welcome back. In this video, we'll be briefly understanding about how to solve problem 25 of Project Euler. We'll be understanding what a Fibonacci sequence or a number is, and I've done a bit of research and wanted to share some facts with you guys about the history and the significance of Fibonacci. So let's go over the history of Fibonacci sequence. The Fibonacci sequence was actually discovered by an Indian mathematician around like 200 BC, and his name was Pingala. Later, it was further developed by an Italian mathematician named Leonardo Pisano. This was his real name, but he was actually his nickname was Fibonacci, uh, which is Fibonacci sequence. So now let's understand what a Fibonacci sequence is. A Fibonacci sequence is nothing but the sum of the preceding two values. For example, if we take f3 and we want the value, we'll have to add the preceding two values, which is f1 and f2, which is 1 plus 1, and we get 2, as you can see it on my screen. Similarly, for f5, to get the value of f5, we need to add up f3 and f4, which is 2 plus 3, and we get 5. I hope you understood this. Please feel free to pause the video and look at my screen and understand the example and read the question. So what they're actually asking us is, what is the index of the first term in the Fibonacci sequence to contain 1000 digits? If you don't know what index is the subscript number under f, which is the Fibonacci number, which number it is. For example, f7 is equal to 13. Here 7 is the index and 13 is the Fibonacci number. So I hope you understood this. Now let's get into solving the question. Here is the code. Let's understand the code by reading the comments, which will make our work easier. Initialize the first two Fibonacci numbers. As they have given us that f1 and f2 is 1 and 1, we describe two variables a and b. A comma b is equal to 1 comma 1. Then the first, let's read this comment. Start with index 2 since f1 and f2 are given. So after f1 and f2 we get index 2, right? So we want to start with index 2. Then continue generating Fibonacci numbers until we find one with 1000 digits. So what I actually did here is I used a while loop, which is an infinity loop. It'll keep putting numbers and running the code until we get 1000 digits. So at the end, you can see here I introduce break. For this infinity loop to end, we use a function called break. So while true colon, then next Fibonacci number is the sum of the previous two. This is the whole point and the whole explanation what I actually told you what Fibonacci number actually is. It's the sum of previous two values. So here we tease the computer what a Fibonacci number is. So C is equal to A plus D. For example, if we take this 2 as C and f1 and f2 as A and B, A plus B is equal to C, right? So 1 plus 1 is equal to 2. I hope you understood this part. Then index plus 1 is equal to 1. Plus 1 is equal to 1. This operator, what it actually does is it keeps increasing the index value. As you can see my comment here, increase the index for the new number. Okay, then the next comment says, check if the new number has 1000 digits. To check if the number has 1000 digits, we check the length in code. So the length, first we convert C into a string, as we can check the length only for strings and not for numbers. So if length string of C is equal to 1000. So print, this is our function. Then let's run our code, and we're gonna break as we hit 1000 digits. Then update A and B for the next iteration, which means that A will be replaced by B and B will be replaced by C. So the code keeps running. I hope you understood this code. Now let's run it and see our answer. Okay, so we got 4782. Let's check our answer in Project Euler. There you go. We solved another Project Euler problem, guys. Thank you for watching, everyone. I hope you liked this video.